everyone! Today I will be showing a tutorial on how to control a 1602 LCD module using the STM32 Blue Pill with Libopencm3. Now currently there are a lot of tutorials on how to control this module, but from what I saw they all use the cube IDE and how. I could not find one that used Libo. So today I'll be using PlatformIO and Libopencm3 to show you guys how to do it. For starters, let's look at just a quick introduction to the 1602A LCD. So it's an 8-bit data bus, and what that means is we basically can use a 4-bit or an 8-bit data interface. Essentially, we can send our data in bytes or nibbles. So in this tutorial, I will use a 4-bit interface. So what this means is I will only use the upper nibble, basically D4 to D7 on the data bus. This just lets me do less wiring, and that's pretty much the only advantage. It does require more coding. The next thing to understand is RS and RW. So RS stands for register select, and its value determines whether the input is a command or a character. Meanwhile, RW stands for read write. Its value decides whether the read or the write operation will be used. Finally, I would say the last thing that you really need to know is E, and E is the data transfer enable. So for this module, essentially when a high to low transition occurs on E, that is what enables us to transfer data. So now that we know that, quickly we can look at the wiring. So this is the wiring I'll be using. So if you want to follow along, feel free to just pause the video, and this is how you can set up the circuit later. And yeah, let's hop into the coding. Okay, so the first thing you're going to want to do before anything is make sure you already have PlatformIO. If you don't have, just look up. There's tons of tutorials to how to install and start. So we're gonna go over here, and we're just gonna create our project, and we're gonna wait for it to initialize. It can be slow sometimes. So let's go ahead and do the STM32, yeah, the C8, right? Yeah. So let me just make sure this is the right one, actually. Okay, sorry about that. And yeah, we're going to choose Libopencm3 for the framework. And for the project name, let's just call it LCD 1602A LCD example. And we're gonna finish, and we're gonna let it initialize. So if you don't, now for me, of course, I've done this many times, so it initialized. I have everything downloaded, but if you don't have everything downloaded, it might take a while to initialize. Okay, so first let's go over here and make sure everything is right. Okay, perfect. So here's our board, and here's the framework that we're gonna use. Okay, so now the only thing we need to do here, we're going to go here, we're going to need a new file, we'll call it main.c, okay, oops, and this is going to be our file that we are going to, that we're going to write the code in. So make sure, pause this video, get to this step if you don't have PlatformIO, or if you didn't have, the dependencies installed and your project is still initializing. Okay, now, let's start the coding. So the first thing that we're going to do is we need to include the libraries that we're going to need. So let me just check here. So we're going to need this one, which is z.h. Yeah, I think this is right. So we're going to need this one, which is the this includes the clock control functions. So and then we're gonna what else are we gonna need? We're gonna need the GPIO.h, yeah, and this is gonna have our GPIO control functions like set and clear, And then we're just gonna need, actually we don't need this, we just need then standard, the standard library for things like std, for things like, or fixed with integers and things like that, and the Boolean library. Okay, so that's all the libraries we're going to use. So now, first things first. The first thing we're going to do is we're going to just, we're going to define some things to make our code a little bit more easy to work with. So now, if you recall from the pictures I showed you, the port and pin. So remember what I said. Basically, I said our RS, I put it as A1, and our E as A3, right? So that's what I did. So first, let's go ahead and so LCD RS port and GPIO A. Okay, and then let's do define. And now let's do the LCD RS pin. And it was GPIO 1, right? So this is, we're just defining the pin port. So this is the port A and then the number 1. That's it, right? And we're going to do the same for E, for our enable. Fine. Maybe just copy this. Yeah, so we're going to do the same for E. So this is the E port was also A. And then the E pin that I chose was 3. So if you're doing a different circuit than me, then make sure to change the port and the pin number accordingly. So the next port and pin, so this is the RS and E port. So let's go ahead and comment that. So RS and E ports, port and pin, right? And what? That didn't become capital. Now let's go ahead and the data pins that we're using. So remember, we're going to use D4 to D7. That's what D4 to D7. That's what we're going to use. And let me check what we define them as. Oh, okay. So we define them as PB0, PB1, PB10, and PB11. And I mean, if anyone is looking at this and is like, what is this guy talking about? We're just taking where we're like hooking up our wires and stuff and connecting everything, and we're defining it in our program. All right. So now we're working. So I, in this example, will be working with D4 to D7. And this is what I'm choosing to wire those two on the board, on the actual Blue Pill. So now let's go ahead and define the data ports. So define. And remember, this is a shared port, right? Because they're all on B. So this is, the P is just an add-on. So they're all on B. So GPIO B. And that's okay. GPIO B. Okay. And then let's define each pin. So now let's define each pin. So like we say LCD D4. So D4 is on the this pin. And then let's just go ahead and copy this. Boom, 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 right? And so we have D5, D6, D7, and D5 is on 1. Oops. And D7 is on 10. And this one, or D6 is on 10, sorry, and D7 is on 11. Okay, so these are just our data bus pin configurations, right? Port and pin. Port and pin. Okay. Okay. So now what this does is this will just make our code essentially easier, right? So now when we're gonna interact with these, we just say like D4, right? So now another good thing to do, because we're using Libopencm3, we're not using like a Arduino framework or something. It's just we're gonna have to make our own basically our own delay function that we'll use throughout the code. So let's just int I equals 0, I less than ms, and multiply by, let's say, 8,000, and it should be fine, and I++, and then or no, we still need to be inside it. Then yeah, we're gonna do some. We're gonna put a nope, right? No. So oops. Okay. So this is just going to wait, however milliseconds we want it to, right? So this is just our delay. So we want it to delay, 1 millisecond, for example. Then it'll delay 1 millisecond using this nope function, just kind of sending in empty CPU cycles. So now oh, I forgot a semicolon. Love C. Okay, so now let's continue with our setup. So the next thing that we should use, we need another function here, right? Because for our E, so let's call this pulse enable, I guess. That's fine. So yeah, basically here, remember I talked about that E. So the E, the enable, basically is what is that's the LCD only reads data when E transitions from high to low, and so we need to write essentially a function to do this. So let's write that now in the setup. So now we're finally going to use those libraries. So GPIO set. So this is the first. This is coming from the GPIO.h, and this is just setting a pin that you choose to high. So the way this works is we say GPIO set, and then we put in a port. So LCD port, and now you guys see why we did all this setup here. It's then much simpler. Otherwise, we would just have to put in and be much more manual. So and then we need to put in the pin. So LCD pin. Okay. So yeah, that looks right. So what are we doing here, right? So this GPIO set is going to set E to high. And now we need to delay. So let's delay. Let's use our delay. And let's just say 1 should be enough probably. So just a small delay because we just need to go from high to low. And now we're going to use GPIO clear to set the E to low. So this will set it back to low. So this is also a part of the same GPIO library. And then let's go ahead and do another delay of 1. Okay, so this is our pulse function. And all this does is it just pulses the E, right? So we set it to high, and then we wait, and then it goes back to low, and then it's during this period that data transfer can occur. Now let's go ahead and write our write function. Yeah, let's write our write function. So static void, and this is kind of a thing that will of course happen a lot if you're new to embedded systems. We kind of have to do our, especially when we're going really low level, we have to do our setup before we write in our main function. Our main function is just not going to really have this much. So the setup is what takes time. So yeah, so we're writing, remember in this tutorial I'm using, so let's just call this write nibble. I'm using 4-bit, so we're writing nibbles, right? We're not doing bytes. So what's gonna basically happen is we're gonna take in a unsigned 8-bit integer. We're gonna call that integer nibble. And the first thing we're gonna do is we're gonna clear all the data lines, right? So we wanna make sure that all of the data lines are cleared. So let's LCD data port, and we're gonna clear everything. So D4, and then where's this go? And then D5. Okay, LCD, and then D6, and D7. Okay, so this is just gonna clear all of the data lines. And the next thing we're gonna do is we're gonna set each bit based on the nibble. So what is that gonna look like? So say if nibble and 0x01, then GPIO set, and it's gonna be LCD data port, LCD D4. Okay, so basically, if the bit is 0, then we set D4. And now we're gonna do this for all of these. So if the bit is 0, set D4, and then if it's 2, we set D5. Or sorry, if it's 1, we set D5. And then if it's 2, we set D6. And then if it is 3, we set D7. So this is just really bad coding practices I'm showing right now. Okay, so yeah, we're setting each bit based on this nibble value that we're getting in. And we're gonna define that later. And the last thing we need to do, right, is we need to call our pulse enable. So we need to pulse E, and this is gonna basically latch the nibble, right? Okay, so now we have our write function. Let's do our send function. So static void LCD send byte. Okay, and it's gonna take in another 8-bit byte, and it's gonna take a boolean. Let's call this boolean is data. Okay. I think. Okay, so this is basically going to be for the RS. So remember, the RS can send a command, for example, like clear, or it can send a character like A. So this function, this send byte, is basically, it's gonna decide, are we sending an instruction or are we sending a character? So that's why we have this boolean is data. So let's just say here, so if is data. So basically, if the if the byte is data, right? Then what we're gonna do is we're gonna set the RS port, and so and the pin, right? So LCD RS pin. Okay, so and this is what this is gonna do. Remember, GPIO set will make it high, right? It'll make it 1. So make RS 1. Yeah. So if we get this, so we're gonna get this byte, and we're gonna get this thing telling us if it's data or not. If it's data, then we're gonna set the RS to 1, which will tell it that this is data, a character like A, right? So now else, so if the thing is not data, if the byte is not data, oops, keep forgetting my semicolons, haven't been using C much. So if the byte is not data, then that must mean that it is a command, right? So we need the RS to be 0 in that case. So we're just going to use GPIO clear. And it's going to be the same thing here. Let's just say RS, set RS to 0. Okay, and now the important thing here is, remember, we are using, or I'm using 4-bit, so a 4-bit interface, but we're working with bytes. So this is kind of where their trade-off is. So a 4-bit interface is going to allow you to basically do less wiring, but because of that, we need to send our data in nibbles. So when we're sending, we can't really send the full byte. So what we need to do is we need to send it in 2 nibbles. So we're going to use LCD write nibble. We're going to use this byte. And what this will do is this will send upper 4 bits. And then we need to use this same function, LCD write nibble, and like this, and this will send lower 4 bits. Okay, so that's the trade-off we're getting, because we're using a 4-bit interface. We're sending our data and writing our data in nibbles. So when we want to send a byte, that means that we need to split that byte into a upper and lower nibble. Okay, and generally it's kind of a good habit when you're kind of sending like a full byte transmission or something. We just throw in a small delay. Right, so just have a little delay of 2 milliseconds at the end. Okay, so now the last thing let's do, let's add a couple of wrappers, some command wrappers for this our send byte function, right? So first of all, let's static void LCD command. Okay, and this will take in a 8-bit command. Okay, so basically, and let's just say LCD send byte, and command false. Okay, and then let's do the same thing, almost the same function, but we're gonna call it data. And bear with me, guys, I will explain everything in a second. Data, and this would be data and true, right? Because yeah, is data. So these are just to help us, right? So if something is a command, yeah, so if something is a command, right, so we're going to take in the command, that means that it is not data, so that'll just be false, and it will then use GPIO clear. And if it is data, then we're gonna send that data in to here, and we're gonna say true, it is data, and then we're gonna use GPIO set to make the RS1. So this is just to help out with that, so we don't need to do this manually later, right? So these like wrapper functions. And now the last thing, I think, or no, we have a little bit more. First, we need to initialize the LCD, right? So let's void. So we need another function. Let's call this LCD init. Yeah. Okay, so this is our LCD initializer. So generally, when you're kind of initializing peripherals like this, again, if it's kind of for hobbyists or a school project or something, it's fine to introduce a little bit of a delay so that it could take time, for example, for the LCD to power up and all these things. So it's good to introduce a delay in these kind of cases. So now we need to actually use the HD44780 datasheet to enter 4-bit mode. So if you're interested in that, you can look up the datasheet and learn a little bit more about it. But I'm just gonna kind of I actually have the commands over here, and yeah. So yeah, so this is what we need to do. So this is the sequence to initialize and then set 4-bit mode, and then we need to use commands. And I have the commands here as well. Let's put that here, and there it is. And then yeah, so this is just going to initialize our LCD, put it into 4-bit mode, and then these are the commands for turning the display on, clearing the display, and moving the cursor. And let's also just maybe add a delay, right? So because this thing will take time, so we want, while it's initializing, we just want to wait for it to initialize, run all these, and then before we do anything else. So yeah, this is the function. I think, yeah, this is everything that we need to initialize the LCD. So the other thing we need to do is we need to set the cursor. So let's call it LCD set cursor. And we're gonna take in, so with the cursor, we're just so we're just setting the cursor row and column. So that means that we need a a row and we need a column, right? Yeah. So we need a row and a column, and we're gonna say I'm gonna make an integer address here, and that's gonna be equals 0. Yeah, and then 0x 0. And this is also, and yeah, so don't worry about this too much, but essentially what this means is like row 1 equals, oh my god, I can't type. Row 1 equals 0x 0 0, and like row 2 equals 0x 40. So that's all this means. So we're just basically the LCD uses DDRAM addresses for its cursor positions, and this function is just setting the cursor row and column. And I think if you're just just trying to we also need to LCD commands, and yeah, this is the thing, right? So 0x80. So this is actually the base instruction. And again, if you're like new to embedded, or you're just trying to like make LCD work, you don't really need to worry about this too much, because, well, I'm giving the code here, but we're gonna take the address and add it to a column. And let me just check this. Okay, so we have the pseudo construction address. Okay, yes. And basically, so what we're doing is we're setting the DDRAM. We're sending a set DDRAM address command. So that's what we're doing here. And yeah, so again, if you're just kind of trying to make the LCD work, or a little bit new to embedded programming, or just trying to do for a project or whatever, don't worry about this too much. This is just something you do it once like this and then you're done for this case. But if you are interested in this stuff, it's good to like maybe look at the data sheet and then look into the base instructions to really understand what is going on here. So yeah, so that is the set cursor. And I think that, so then the last thing that we should need before we start our, no, we will need a function to go through each character in the string that we're gonna write, because in our main function we're gonna have a string, and that's what we want to LCD to display. So basically we need a function to let's call it write string const char str. So we need a function that is just going to go through that string and like go through each character and tell the LCD what to write. And so while that's a very basic while LCD data R++. Yeah, so this function is just going to oopsies, this is okay. Let's see, is everything correct? Yes. So this function is just gonna go through each character and send each character, and then yeah, we're gonna add it to the LCD will display it. So now we can finally, after all this, we can finally do our main function. So let's start. So the first thing we're going to do actually is we need to enable the clock on each of our GPIO. So we used on each of the ports. So we used A and B. So that's going to be RCC perif, where is it? Clock enable, this one. And then we're going to say RCC GPIO A. And we're going to do the same thing for B. So this is just enabling the clock for our ports. Okay, now we're going to set the GPIO set mode. So we're gonna in our main function, you see all of our kind of other setup functions are going to be what are, setting ports on, off, setting all the stuff, right? So our main function is not going to be doing that. So basically what we need to do is we need to set our ports as push-pull. So let's, so I'll show you what I mean by that. So let's start with the RS port, right? So first the RS port. So we're gonna, basically we're setting the RS pin, which was A1 as output push-pull. So GPIO, so what we need to do that, it's, let's see, 2 megahertz. And let me just make sure what, okay, so then, oops, no, that's not what I meant to do. Then GPIO, the function is CNF, output push-pull, yeah, here it is. Okay. And then LSD RS pin. Okay, so this will set our RS pin as an output, and we need to do the same thing for the E pin and port. So E ports, and change this to E. So okay, yes, and we also need to do this for our data ports. So let's see, data port and pins are gonna be LCD D4, LCD D5, LCD D6, LCD D7. Okay, so now we set all our GPIO to output push-pull, and the next thing we're gonna do, we're gonna initialize our LCD. So that's just simple. We just call it LCD initialize, and then we are gonna set the cursor. So LCD set cursor, and then all that's left then. Okay, so I didn't make it so that the cursor should, okay, then let's just set the cursor 0, 0. Okay, sorry about that. Okay, we set the cursor to move to row 1, column 0. All right, so now now we just can use LCD right string, and let's say hello world. Okay, and then let's say while 1, right? Because this will just keep our program running forever, infinite loop. And okay, so the next thing, so our code looks like it's complete, and that should be everything now. So the last thing to do is we need to build it. So right here, there's a check mark. So we're going to click build, and if everything is fine, then it should successfully build. Just give it a second. Wait, let's see. Isn't the prototype sent upper? Did you mean LCD? Oh, okay. Looks like I made a couple of typos actually. Warning function. Okay. Oh, I did some typos. Interesting. Oh, how did I not notice that? Okay. And then oops. Sorry about that. Okay, sorry about that, guys. And let's rebuild here. So it was just a typo. Give it a second to build. Okay, so yeah, sorry about that. I just did a typo with the nibble, and yeah, so press the build, and as you can see, it's successfully built. So the next thing you're gonna do is you're gonna take your wire up your STM32 with the LCD, and just how I did it, I showed the schematic. Or if you will do a different way, just make sure that you wire the things correctly, and then you can plug in your STM32 with the ST link and go ahead and press upload. So then give it a second, and boom, it is now uploaded. So remember to have your ST link. You still need it even if you're using PlatformIO, and make sure all of your wiring is correct. If your wiring is not correct and you plug in an ST link or some kind of power source, the LCD will not light up at all. If it is correct, even if you don't boot any code, the LCD should light up. So that's just something to look out for. And yeah, as you can see, there we have it. Hello world. So thanks for watching, and I will put the GitHub link to the code in the description. Thanks.